Hello, my name is Logan Echeveria. This is my EEC 10 final project, and I'm a student in winter of 2018. So starting with the LabVIEW program, we have our power versus frequency graph here. We have our amplitude versus time graph, and then here's our equalizer. So if we want the bass to be higher, we can use the scroll. If we want the midtone to be higher, same thing, treble. These just work as high pass and low pass filters. As well, you can change your volume, which just changes your amplitude over here. This section is for the delay feature, so if you want to wait to record, you can click this button, turn it on, and then you wait. You can enter how many seconds you want to wait. So if you want to wait 9 seconds, enter 9, keep it at 2 for now. And this displays how much time has passed, and when it hits 2, then everything will start running, and then you will record a sound file as well. Down here, they just display, these are different displayed values. So we have the root mean squared values from the left microphone, and then the root mean square value from the right microphone. And then off to the right, we have our Lmax and our Rmax, and those indicate the two maximum amplitudes coming from the two microphones over here. We'll get into the hardware in a second. Root mean square values are used for finding the correct angle to send to the servo. And then our Lmax and our Rmax are used to see if our amplitude is high enough, then we know we do indeed want to send a value. But if it's wavering around, these small values, negative, or not going to be negative, but 0 to 0.1, then we know we don't want to send any value. But if it gets up to 0.5 is what I have in the code right now, then we're okay, yeah, we want to send a angle to our servo. This shows me up here the angle that was sent. And then right here is the COM port to my servo motor and my tibia. So that's kind of the code, or the LabVIEW front panel. We'll get into the code just a little bit, quick overview. So I kind of messed up. I made a case structure over here, but we're always setting this outside case structure to true, so there's only going to be one route for the code to take. And then the delay button's outside. If the delay button's true, we're going to go in here and wait slightly. We use the elapsed time function, and then once the time has elapsed equals true, then we're going to break from the loop and then get into our file writing. And then, as you can see here, we just have the display time. This is an input, and then this is showing the user how much time has passed. So we go over to the file dialog. This is just used for writing the file. It is using a WAV file. You can use, any music file you want. You can do MP3, whatever. You can change these as you wish. This is just to make it more organized on my laptop. And then the false look just like the same thing, except for without the wait function. So this is just the same thing you just saw, which will create our file. So moving over, this code was given in Lab 6, and this just shows the 3 different filters that we have that correspond to the bass, midtone, and treble. Works kind of as an equalizer, high pass, low pass filters, as I already mentioned. And then right here, I'm displaying the data corresponding to the filters. So note that this data isn't connected over here where it just first came out. It's after the filters. So after the filters have already been applied, then we're displaying the data. Up here is where we're writing our actual file. This part's pretty messy just because this is what I had to change most to get the servo to move. We start off by breaking the 2 signals up, and then we get this little function right here. This converts from dynamic data, which is a signal our MIDAC is sending, into a waveform. And that waveform is going to get sent into an array, and that array gets sent to a matrix, which then gets used for our max values right here. But before that, we just go to our root mean squared. So we have our right root mean squared, our left root mean squared right here, and then the same thing over here on the right, right here. And then those get sent over here, and that goes there, that goes there. What I have going on here? Sorry. So this is the use for the equation that was given by our TA June. So it's just saying to this is like all finds the angle. So if we're just trying to find which one's bigger. So if our left root mean square is bigger, it's going to go to true and output the left mean square as our max for the 2. And if our right's bigger, it's going to go to false and then give the right mean squared as our max value. I believe the formula that he gave us was you take your left and then you subtract your right and then you divide right here by your max. And then you're going to multiply by 90 and then you'll have an array between negative 90 and 90. So you need to add 90 again to get the value between 0 and 180. And then, so now you have your final angle that you want to send. And that goes over here. Oh, sorry. That goes over here and it displays what angle we have. This is kind of misleading because it says angle sent, but this isn't actually sent until we get over here to our Visa. To our serial monitor. So way back at the beginning of the code, we had our resource name, which selects the COM port and whatnot. And then we have our serial, pretty much all default values. You can change it if you want, but this is how our setup is used. And that goes into the loop. So now we have our Visa set up. So we have, we need to check if something's true first. So we don't want to just constantly send angles to our servo. We want to make sure that we only send it if we're trying to make noise, like a snap or a clap. So we take the max values back here from our arrays that we made. We take our left max and our right max, and when they're displayed. And then what I found, I'm using 0.5. If it's a louder room, you can use like 0.8, maybe even 1. But if it's a silent room, mostly not a lot of background noise, you can use 0.5. Then you compare if your maximum amplitude is greater than 0.5 on either of these, either your left or right microphone, then we know, yes, we do want to send a value to our servo. If it's not, if it's false, this is the OR right here. So if either one of these are true, but if they're both false, then we can go here and just close our Visa. So basically, we'll focus on the true part. We have our numbered string, so the angle gets put into a string, and the string gets sent to our servo. I'm using our Energia program right here, and then that gets sent to the servo, and then hopefully it goes to the angle. So that's pretty much my code. Here's the hardware. So we have the MyDAC connected to my proto board with the 2 microphones over here, microphone 1, microphone 2. Not the best soldering job, but it works. And then we have our TI Echeveria, which is connected to the servo, which also connects to my laptop, which is in COM port 5. So let's just check it out real quick. I want to start with no delay, and then we turn up the volume a little bit so I can play my sound a little bit. We're going to start it, and then right away it's going to ask, what do you want your WAV file that's going to be recorded to be named? I just keep it the same one, so I only have one WAV file being made every time, which keeps writing over it. But if you really want to make your own, you can rename it. And okay, and then you can see when I talk, the amplitude gets bigger, and then this shows the frequency, what frequencies have the highest power. So if I were to play a tone, like whistle, right around 1,000 hertz is where that was, because the hertz spikes right here. So you know what frequency is being heard the loudest. You can change these as you wish, but there's no real point right now. And the delay we'll get into in a second, but I just want to focus on the servo right now. I don't really have the angles calibrated right. So when I snap, it'll move. You'll see the LEDs light up. You'll see the servo move, but it's not necessarily going to be pointing towards where my snap is coming from. It's more just sensing and moving. I didn't get that far, so let's hear a snap. You see the servo does move. Everything's communicating correctly. I got the communication set up, but the angles just aren't set to point in the right direction and have enough time for that. But nevertheless, that's about how far I got. We'll show the delay feature real quick while we have time. So let's say we just want to delay 2 seconds. We'll start our program. The delay function or button is on, and then we'll press play. We'll hit our audio file. It'll wait 2 seconds, as you saw right here, and then it'll start recording. If you want to make a long time, you can wait 10 seconds if you want. If like you need to set up, let's say you need to start the program and you just set up what you want to record. See, it's already recording down here. So we have 3, 4, 5. None of this will be recorded. And then once it hits 10, perfect. So now it should be recording, and then we'll actually check in our audio file to make sure that everything was recording when I wanted it to. So the first thing that should be heard on my audio file is perfect. So we come here. Here's my project that I just recorded. Perfect. So now it should be recording, and then we'll actually check in our audio file to make sure that everything... Hopefully that was heard on my phone. We'll just do it one more time. Again, the first thing that should be heard is perfect. Even though the program was running, but while I was talking, it doesn't start recording until I say perfect, after that 10-second mark. Perfect. So now it should be recording. So this goes on for 9 seconds, but you get the idea. So that's basically my project, and yeah, thanks for watching.